So the next talk up is going to be Jan Stoica. Jan was Matei's advisor at UC Berkeley. He's a professor there. He's also the co-director of the AMP Lab. He is the CTO at Conviva and the CEO at the new company around Spark, Databricks. And Jan will be talking about turning data into value.
Good morning. Thanks everyone for coming. So as you can see, as Andy mentioned, here I am wearing multiple hats. So before starting the talk, I want to make one thing clear. This talk is not about the value proposition of Databricks. This talk is about the value that Spark, Apache Spark, brings to its users. So Hadoop made it easier and cheaper than ever to collect data. And today, we collect a huge amount of data. And it's not only that, but the data we collect, it's predicted to grow exponentially. In fact, according to an IDC report, the data is predicted to grow faster than the Moore's law. So now, all these startups and big companies alike collect this data, and they collect it with one goal in mind: extract value out of the data. However, there is a big gap between this aspirational goal and reality. On one hand, companies like Google and Facebook and others have demonstrated that there is a huge value in the data. On the other hand, most companies today do little with their data, or at least they do less, much less than they would like to do. So why is that? Well, this is because it is fundamentally hard to extract this value from the data. The data is not only massive, but it's unstructured and dirty. People want to ask complex questions. And the processing and analysis tools we use today are still in their infancy. So therefore, at least part of solving this problem is developing new tools that are faster, more sophisticated, and easier to use. So let me spend a little bit of time to illustrate what people mean by turning data into value. So first, they want to get insights from the data. For instance, why is the user engagement dropping? Why is the system slow? Is there a spam or DDoS attack going on? But more importantly, people want to use data to make decisions. Decide what features to add to a product, provide a personalized treatment for a cancer patient, decide when to change an aircraft engine, or the example you all know about is decides what ad to show. Much of our work in the AMP Lab and in Databricks is driven by this belief we share with many others that the data is only as useful as the decision it enables. So what does this mean? Well, this means that we want interactive queries, because faster decisions are better than slow decisions. We want also to be able to query the streaming data, because decision on the fresh data is better in general than decision on the stale data, right? Imagine, so for instance, in the case of fraud detection or detecting a DDoS attack, if we are too slow, we may be too late. And finally, these decisions do not require only SQL queries. Some of them do, but in general, they require also more sophisticated computations, such as statistical, machine learning, and graph-based computations. Examples are anomaly detection and trend analysis. So, not surprisingly, our goal has been to address these challenges. And for once, we wanted to build a framework which unifies the support for the main computation model, the batch, interactive, and streaming. And in addition, it makes it easy to develop sophisticated algorithms such as graph and machine learning. So now I was talking quite a bit about unification, and also Matei mentioned it. So let me take one example to illustrate it. So let's consider today's state-of-art analytics stack. So what do? We start with deploying Hadoop. So we collect the data, and we have the ability to perform quite sophisticated batch computation on it. And then we may want to use Hive or Pig to allow users to query the data using SQL. But then the user will ask to have access to the interesting data, to the interesting results much faster. So what we do is that we add maybe HBase or something like Impala, or maybe if the data is small enough, maybe something like MySQL, to enable interactive queries on this historical data. But then users want to follow the most important metrics in real time. So then what we do, maybe we add streaming, right? And like something like Storm to allow real-time analytics. So what is the challenge with this approach? So for once, we need to maintain 3 different systems or stacks. This is, in general, expensive and complex. And there are other difficulties. For instance, in all this stack, we compute metrics, and often we compute the same metric. But now you compute in different stacks, you use a different development environment and so forth, and maintaining that metric consistent, is very hard. To just give you an example, if today I am asking what was the concurrent number of users at 9 a.m. yesterday, that result should be the same with the result when I was looking yesterday using the streaming at 9 a.m. Furthermore, these different systems may require to share the data, and sharing the data is not easy because, again, you may need to copy the data and so forth. And therefore, it is hard to provide some functionality. One example here is providing interactive queries on streaming data. So our solution to this challenge, of course, is Spark. And as Matej mentioned, Spark is an in-memory parallel execution engine which provides support for batch and interactive applications, and also provides very good support for iterative algorithms. On top of that, others and ourselves build a set of components or projects. Spark Streaming provides support for streaming. So now we have unified support for batch, interactive, and streaming. Then Shark and BlinkDB provide support for interactive SQL-like queries. And then new components like GraphX and machine learning libraries, MLLib, provide support for sophisticated algorithms. So to put unification into perspective, let me use an analogy. And this is evolution of mobile device ecosystem. And it turns out that if you look at many technologies, maybe not all of them, they go through 3 phases. The first phase is that when for the first time you provide a new capability. Then it's some kind of a specialization. Maybe people are going to come up with new uses, and they are going to have different instances to provide these uses. And then the last stage is unification. So in the case of the phone, of the mobile devices, the first cellular phone provided for the first time the ability of people to call from everywhere, but these first instances were far behind the potential of the technology. The next stage saw an explosion of specialized mobile devices. Mobile phone, PDAs, GPS devices, MP3 players, handheld video games, video cameras, and so forth. And the next stage, as you guessed, is the smartphone. So the smartphone unifies the functionality of these devices. And while we can argue whether it provides a better image quality or the signal for the GPS it's better with the traditional GPS device and so forth, we cannot argue, or it's very hard to argue against 2 things. First, it's a huge convenience and easy of use having all this functionality in one device. But the second, and more importantly, having this unified functionality in one device allows to build applications, new applications which are not possible before. So some examples is leveraging the crowdsourcing for maps like Waze. The other example will be the mobile handheld games. And maybe another example is that the ability to take pictures and share instantly with your friends. So all of these applications were not possible before, and this is what makes it very cool. Now, we believe that in the big data space, we see a similar evolution. So Hadoop MapReduce provided for the first time the ability to users to process huge amount of data cost effectively by leveraging the commodity clusters of servers. And then people, soon after they were able to process this huge amount of data, they wanted something more, like always. And they wanted the ability to do streaming, to do interactive queries, to do more sophisticated computation like machine learning, graph-based computation, and so forth. And therefore, we've seen a large number of different and very interesting cluster computing frameworks being developed. Now, we believe that the logical next step in this evolution is unification, and Spark represents the first instance of this next step. And we hope and we believe that Spark is like smartphones, not only unifies the functionality provided by many other cluster computing frameworks, but will allow users to develop new applications which are not possible before. So next, let me give 3 examples which illustrates how unifications improve the existing application and maybe even provides new functionality not available before. So the first one is unifying the real-time and historical data analysis, and this results in a system which is easier to use, build, and maintain, and cheaper to operate. The second example is unifying the stream and machine learning, and this allows to provide real-time diagnosis and decisions. And finally, I'm going to give as an example unifying the graph processing and ETL, which allows to faster data mine a graph and present the user the results back to the user, so therefore increasing the user experience, improving the user experience. So with Spark, one can unify real-time and historical analysis by building a single system consisting of Spark and its components, Spark Streaming, and eventually Shark and BlinkDB. This implementation will support streaming, batch, and interactive computation, like I mentioned before. And the resulting system is not only easier to use and maintain and deploy, but than maintaining 3 separate stacks, but provides also new features. For instance, it provides you the ability to perform arbitrary queries on the stream data. Furthermore, this unification simplifies the development. So here is a code snippet computing the word count from a file. So this is a batch job. And here is a code snippet computing the word count from a network stream. And it updates this count every 10 seconds. So this is a streaming job. And I'm not going to go and explain what's happening here, and I'm not going to ask you to do that. What I want to show you here is that if you look at the core of this code snippet, it's basically the same. And this not only simplifies the development, but also makes it trivially to maintain the metrics computing by the streaming stack and the batch stack consistent, because you can use the same code. To unify streaming and machine learning, one needs only to run Spark with Spark Streaming and our machine learning library, MLlib, and later the new components we developed, MLBase. And this will allow the users, as I mentioned, to perform sophisticated real-time diagnosis and decisions. Now, the ability to timely detect frauds, denial of service attack, or to early notify of service degradation or failures, as you can imagine and as you know, can have huge savings, provide huge savings for the companies. Finally, GraphX, a new component which will become available very soon, will allow one to unify graph processing and ETLs. So why do you care of this? Now, any kind of user-facing service now has its own social graph, and of course, it wants to mine this graph. So what are your alternatives today? So first, you can use Hadoop, maybe with Mahout running on top of it, to data mine these graphs. However, this is quite slow, although you can achieve very large scales. To address this challenge, recently, several graph parallel computation engines have been proposed. One example is GraphLab. And they are performing very well. They scale very well, and they are very fast. They are actually, for the same kind of operations, order of magnitude faster than doing the same operation in Hadoop. However, if you look at the entire processing pipeline, the graph creation and post-processing are still handled by Hadoop. Between these graph parallel engines like GraphLab do not support these ETL operations. So you have to perform data creation in Hadoop. You have to share it with the GraphLab through HDFS. So if you add everything up and you look at the entire pipeline, yes, you have an improvement, but it's not as impressive as you originally hoped. So by doing with GraphX allows you to unify the ETLs provided implemented in Spark with graph parallel computation. So therefore, the graph creation can be much faster. The share of the data will happen through memory, which is again much faster. And if you put everything together, you are going to get with a much, much faster pipeline, which again will allow you to data mine, present the results to the user, improve the experience of the users, and of course, maybe improve the quality of the targeting. So switching the gears, let me spend 1 minute of where Spark is today. So from the adoption perspective, we believe that Spark is pretty much crossing the chasm and is becoming widely used in industry. And here are a few data points. At the beginning of this year, Spark and Shark have been available, have been provided, EMR, Amazon provided EMR support for it. Then in summer, OneDisco announced support for Spark and Shark. Then in September, we created Databricks, which will support the development of Apache Spark and other components around it. And just a little bit over a month ago, we announced a partnership with Cloudera. And we are quite excited very excited about this partnership, as according to this partnership, the Spark will be integrated with Cloudera Manager, and later will become part of CDH distribution. So furthermore, with Cloudera, we will be able to provide enterprise-class support and professional services for Spark users. So now, let me put my Databricks CEO hat on. And while, again, we are still in stealth, so I cannot reveal that much, but I can say what we are committed to. So I want to be unambiguous here. So we are committed deeply to open source, because we fundamentally believe that for any successful analytics stack, that stack must be open source. We are also committed to improve the integration with Hadoop. We want to enable every Hadoop user to take advantage of Spark, running on their own data, already stored in Hadoop. And finally, we are committing to work with our partners to make Apache Spark successful for enterprise customers. So in summary, Hadoop made it cheaper than ever to select and easier than ever to collect new data. And startups and enterprises alike collect a lot of data with one goal in mind, extracting value out of the data. However, the reality is that today, few companies do so. With few notable exceptions, most of the companies don't do much with their data. And this, one of the reasons, is that today's tool to to extract this value out of the data are still in their infancy. We argue in the past, and in this talk, we presented hopefully one of the strongest arguments that the unification should be one of the cornerstones of the new tools for data analysis and processing. And Spark is in this unique position, providing already unified support for the main computation models, batch, interactive, and streaming, and for some of the key programming models, such as data parallel and graph parallel programming models. In this talk, I gave a few examples of the application that unification makes them easier to use or will enable in the future. And during this program, you are going to see a few more exciting applications, and this hopefully will be indicative of the things to come in the Spark community. Thanks.
Thanks, Jan. So we actually have time for 1 or 2 questions right now. The way we'll handle questions throughout the day is we need you to stand so that we can get you on camera for the streaming folks, and wait until the microphone has come to you to ask your question.
Hi, and thank you for the talk. I'm curious, more strategic and less pure technical is, I'm a Hadoop user for years, and I've been interested in Spark. And my initial concept was, wow, I like Spark, and I like it better than Hadoop. But what are you trying to do? Are you trying to co-evolve or move the evolution of Hadoop and hoping to work with it, involve something new? Or are you trying to directly compete with Hadoop and do a better job than Hadoop? To eat it, basically.
Okay, very good question. So let me be very clear. Very clear here, like I mentioned, we want to deeply integrate Spark with Hadoop. And if you look at all our efforts, some of our efforts recently was to make Spark work much better on top of Hadoop here. So we do expect that Spark to coexist and enhance Hadoop stack. It's again, what we are trying is again to provide the ability of the users, Hadoop users, to also use Spark for their data processing in conjunction with other tools they have. So the goal of Spark is not to replace Hadoop. Okay. We couldn't even do that because we don't have a storage layer and anything, but just hopefully that clarifies things.
All right, one more question.
So maybe I'm the heretic in the room, but one of my main concerns with Spark and the ecosystem in general is actually LLVM and the increasing need for runtime code generation. And I think you've seen with the increasing popularity of Python that being able to compile, essentially compile code to a native kernel and then insert that into the Spark runtime would be important, and how you've been thinking about that.
Yeah, so it's again a very good question. So 2 things there. So looking forward, one of our main priorities it is to support Python. And as you know, this is very popular through our users. And about the LVM and this kind of technologies, as you go forward, we do look to, to incorporate some of them. There are some efforts to provide the bytecode generation from Intel in the context of Shark. So, these are very interesting technologies we are looking to leverage in the future.
All right, thanks again, Jan.